Alright guys, before we do the final drilling through into the boiler to mount the regulator, we have a bit of an issue with this face here, particularly that edge there. That's got about a 1/4 mil taper on it. So we need to get that machine nice and flat, so when we offer it up to the cylinder and offer it up to the boiler or the firebox wrapper, everything's going to be nice and square. And it's going to pull up nice and evenly when she all gets bolted up. Now the customer's given us this former, and I'm assuming this is a former just to check the radius of the cylinder when it was machined. We can't use this as a setup jig. It's about 2 millimeters out on the bottom. That's just a rough sawn face on there, and squareness here. We're about 1 millimeter out. So we can't use this as a machining jig as it is, or a setup jig. So we're going to spend a bit of time, get this all cleaned up, get it all squared up properly so that we can use it as a setting jig, and we'll set that regulator up on it. We'll use our little test indicator, and we'll get everything squared right up on this, and give the face a lick and square it up, and we'll see how we go. Alright guys, we've got this fixture plate machined up dead square all round now. I've used one of my tenon blocks and a parallel in behind it to get it set exactly parallel to the table, but I've also checked with my test indicator along the face of that block as well, and yeah, it's spot on. Now I've got this clamped down via the flanges, and I've released this a number of times, pulled it around until I've got the dial indicator or the lever indicator reading square. Then I've nipped it up, and it's always pulled off about 0.1 mil. And about 0.08 mil. Back to 1. So I'm satisfied that I've got this curvature that's on this bracket. I've got that mating beautifully onto that fixture there, and that's just a machining error that's been put into that. So we're going to take that out. The other one is up and down here, and I've got that within about 0.35 millimeter out of square. Alright, so I've got a 0.3 millimeter feeler there. I'll poke that in there. It's just off the bottom of the flange. So I'd say about 0.35 millimeter out of square in this direction, and we're about 0.08 millimeter out of square in that direction. So I want to come down with an end mill and just gently lick that face and get that squared up. Then we can remount the boiler up again, get this mounted onto the boiler, clamped up against the cylinder in position. I'll use my transfer punches, we'll punch through, we'll take it away, and then we'll drill and tap for the M5s to get this mounted into place. Alright, I'm just going to very lightly dust this across. I'm going to make sure I'm not cut milling. I don't want to try and drag this in. It is clamped down very solidly, but I just don't want to take any risks with this at all. Right, it's given us a full clean up and a very nice surface finish. Alright, I'll break this down and I'll see how that offers up onto the cylinder. Alright, let's off frame up. Right, we've got no rock in that whatsoever. I'm very happy with that. Beautiful. Right, so I can get that clamped up and I'll get that transfer punched through, and we can get set up to drill and tap for these blokes. This is going to be I believe an O-ring seal is going to be, or an O-ring groove is going to be machined into that to seal it up. So we only just took the lightest of dusting off that. We only just cleaned up down the bottom. And if it's a tiny little bit that hasn't quite cleaned up, but it's not an issue at all. Alright guys, we'll come back when we're ready to start drilling and tapping. Alright guys, we've got a little bit of a problem here with this. So I can't get a socket cap screw into there, it's too tight. So I've got one into here. So we can do that up. Now we've got a little bit of play there so we can get that married up nice and square. The issue I've got is one each of these socket-headed cap screws is biting on the edge of the so I do this up because it's catching. It actually pulls this around a fair bit. And I'll show you the reason why that's happening. I'll get this off and I'll show you. Alright, if I put two spigots through and we get to an intersection point, that is roughly working out, I'd say, probably an intersection of around 65 or so millimeters is what that will be. The intersection point needs to be up here at around about 90-95 millimeters, so quite a bit more. So these holes are tapered in a lot more than what they should be to meet the radius of this outer firebox wrapper. So I'll take these out and I'll show you what the end result is. So the end result is that the cap screw, or probably going to be a nut that's going to go on there, isn't going to seat squarely on that counterbore. You can actually see, I don't know if you can see it there, but it's actually pinging right on that corner there. So when we do this up nice and tight, it kicks that around a fair bit. So the customer's going to have to either put tapered washers in here or re-counterbore to get those counterbores squared up to where I've set the centre line through to the centre line of that firebox wrapper. Right, so we've got two more holes to do, so I'll get stuck into those now and we'll see how things pan out. Right, we'll set up, we'll tap those two and see how we're looking. Alright, we've got all these holes now drilled and tapped. I didn't want to put you through the pain that I was going through. That tap is getting a little bit blunt. And it's maybe done 6 holes. So anyway, we've got them all tapped through. I'm not going to do these up tight just to show that they do go quite nicely and quite easily. So that's all nipped into place. I'll just get the cylinder and we'll marry that up to it. Let's just make sure we've kept things nice and square. There we go, I'm very, very happy with that. That's dead flush all the way around. Whichever way you look at it. Alright, so there's not a lot of play in these bolts. I haven't even nipped them down. There's just the tiniest little bit of flexure in there, so I'm going to let the customer open these holes out a couple of thou. And as I said, the customer's possibly going to have to reseat those small counterboards for the heads that have to button down on it. But no, all in all, I'm very, very happy with that result. And thank goodness that's the last of the tapping. Well, for the small stuff anyway. I do have some quarter BSP taps that I need to do for the inner firebox for the stays, but that'll be a breeze compared to these small ones. Just need to drill a hole through to feed steam into the regulator, and I need to do another hole for a bushing for a whistle. So we'll break this down and we'll get that set up, and we'll get started on those two. Alright, so that's a 7mm drill that I've put in for the steam admission into the regulator, and I've used a cold bolt drill for this one. As you can see, shocking stuff to try and drill to. Alright, I've got one more hole that I need to do, and that's for the whistle bush, so I'll get this orientated, we'll get set up. Once again, I'm going to drill and then bore it to open it up to make an exact size for that bush that I've got. Alright, I'm just going to do this mainly for my brother Andy's sake. Andy, I know you're worried about whether this was going to be central into your weld point there where you've back welded, and I can tell you, mate, it is absolutely spot on central. So you did a very, very good job there, mate. That's gone smack through the weld joint. Righto guys, this is not easy, I can tell you. So what I've done is I've gone through with various sized centre drills to get that hole opened up as much as I can. And I've got a through hole now. I've got a 10mm carbide end mill in here at the moment that I'm cutting with. So I'm going to open it up with that, and then I'll open it up with a 1/2 inch carbide and finish it off. Then we can get out and then we can bore it. Alright, let's just keep going with it. Obviously when I'm doing this I've got to be so careful that I don't let this thing rub. I have had it rub a couple of times, and yep, you can really feel that it has work hardened, and you've really got to put a bit of pressure down and things get a little bit unstable to try and break through that very hardened face of a copper fail. So now we're almost cutting full diameter, which is making life an awful lot easier. At least we have a hole in there now. Whew. This is incredibly stressful stuff to machine. Oh dear me. Alright, we'll try with a 1/2 inch now and see if we can open that up ready for boring. Right, so I've got a 14mm end mill in here at the moment, and I've had some exciting moments. I'll tell you what, showing this stuff certainly isn't for the faint-hearted. Oh, well, I don't know if that was as stressful for you as it was for me, but I'm exhausted. Alright, all I need to do now is set up the boring bar, or the boring head, and I'll get that cleaned out to 15mm. So we'll get that set up now, and then we've just got that little light machining to do on that pad at the front of the boiler. Right, so as you can see, we're set up with the boring head now. I've already given that just a very light lick out, and that's bang on 14 now, so that was just a very light dusting. Right, we're going to take 0.3 out this time. Righto, so that was 0.3 off the radius, so it should leave me with about 0.6 left to go. I'll just show you something I've got set up just to sort of give you a bit of or give me a bit of an idea of the vibration, whether it's getting too much. And I did this with the end mill, so I'll just back up here and show you. I've just got my soft hammer sitting here, and I can sort of judge when that really starts shaking that I'm in a bit of trouble, and I've got to back off fast. So it doesn't take much for it to kick off. So just a little indicator for me to let me know how that cut is progressing. Alright, I'll keep going with this boring head out to the last, and we'll bring you back just before we finish. That's our bush in place now. That's how she's going to look. So that's a very light sliding fit in there. Just oversized for size, so I'm happy with that. Alright, we'll set up and we'll just give that front pad a bit of a dusting, and we're done. Well, just before I break this setup down, I thought I'd show you, I've just put a bar across the outer firebox there as a stop. The cutting action was trying to bring it back this way, so that certainly took a lot of that movement out whilst we were machining it by putting this foot down the bottom to push up hard against that outer wrapper. It worked quite well. Right, I'm going to give this a light dusting. I've just done some trial checks on this. I've used my indicator to get the barrel squared up. And I've checked it against here. We've got around about a 0.2 to 0.25 taper on this, so when we finish machining this, it's going to come up parallel with the edge of the board. Righto, all done. I'll deburr that. And that's it for this section. As I said, I've got, when the inner firebox wrapper goes in, I've got to do the stays, drill and tap stays, and drill the holes in the outer firebox to allow the stays to pass through. Right, just as a final check on this, I'm just going to use my depth indicator. I'll get away from the weld zone there. Just measuring up at 5.58. 5.53, 5.55. So we're only talking around about, 0.02, 0.03 of a mil. So that's pretty parallel all the way through. So we've got that cleaned up nicely. All right, guys. That's it for now. The next job I'll need to do on this is when Andy gets the inner firebox wrapper in place. I've got to drill through that outer wrapper into the inner wrapper, BSP tap the holes on the inner wrapper to fit the new stays, and those stays have also got to be single point thread cut as well. So a little bit more work for me to do on this, but yeah, we're getting close. It's looking good. All right, guys, we'll see you soon.